All right, everyone, we'll probably get started as the last few people trickle in. So I just want to let everybody know, my name is Andrew Braham. I manage the cloud network engineering team at Netflix. Just to give you a bit of background on my team, we're primarily responsible for managing all network components within the AWS environment. It's like ELBs, NAT Gateways, Direct Connect. We're also responsible for our DNS infrastructure, troubleshooting any sort of instance connectivity, and we also build tools and services to help improve the visibility within the network. Co-presenting with me today is Lori Ferrioli.
Thank you, Andrew. I'm very excited to be here today telling you about our adventure moving from EC2 Classic into VPC. I'm the Senior Program Manager at Netflix, who was responsible for the migration program. For those out there that don't know anything about Netflix, Netflix is a predominant internet television network that has over 86 million members right now, and they live in more than 190 countries. Our members watch over 125 million hours of television shows, documentaries, originals every single day. You might not know that we didn't start in the cloud. We actually started in our own data center where things were going pretty well. We were happy with the services that we gave our customers until 2008. A database outage meant that we couldn't ship DVDs to our customers for 3 entire days. Probably seemed like a long time when you were waiting for a DVD to show up in your mailbox. We selected Amazon Web Services to go into to be our cloud provider, to give us flexibility, reliability, and expandability, and a presence in the cloud. One of the other things that we did is we decided not to forklift our applications from our data center, but actually to move it with thought into the cloud. We moved away from a monolithic application model to a distributed and microservice model. That allowed us to develop a very resilient environment that had reduced dependencies between services. It took us a while to get there, but in 2010, we were able to launch out of Amazon's US East environment. We also optimized for EC2 Classic. All of the networking was set up that way, all of the areas that we needed to ensure that we had performance and reliability. 2011, we went into our second region, into EU West. We had about 20 million or 30 million members at that point in time, and we opened our services to Latin America. By 2012, we continued developing our environments, our tools, our telemetry, our monitoring, and our services optimized for multi-region deployment as well as reliability and EC2 features. 2013, we opened our third active region on US West. By 2014, we've pretty much moved from our data center into the cloud. What we've done essentially is built a mountain of EC2 granite that we now need to move into VPC. This system was actually working very well for our customers. They were delighted. We were delighted. Resiliency was up. We had a lot of good performance. And so today we're going to talk about why we made that decision to move, what that granite mountain was made out of, how we managed to move it in the time frame that we had, and what we learned. VPC provided a lot of advantages that we were looking for. One of the key areas we wanted to explore was the area of configurability, being able to form our networks the way that we wanted them to be formed. And Andrew's going to talk about that in detail. Another area that we were looking for was the increased performance, reduced latency, as well as better throughput. And of course, For our diagnostics, we were looking for the flow logs that would give us insight into the traffic that was moving before our instances. And last but not least, we were looking for those new instance types and data regions that were going to be opened to VPC only. Netflix is big. One of the things that we needed to do is we needed to look at the entire environment. But there were special pieces that were going to make the move easier. Some of them were our essential tools. Tools like our delivery system, Spinnaker. Spinnaker not only needed to move into VPC without experience any outages, it also needed to provide a way for our service teams to move easily and quickly, and developed a one-click migration button. That button allowed teams to move their pipelines and their ASGs seamlessly. Spinnaker actually was the one that did the heavy lifting with duplicating the pipelines and ASGs, creating security groups and making sure they were aligned, as well as attaching ClassicLink, and not but the least, to have the name conflicts resolved. We also have a large real-time telemetry environment that reports over 3 billion metrics every single minute. This system is called Atlas, which has been open source, and it's our window into the health of our environment. Without having the tool to see the visibility, we would not have known whether we were doing well in our migration, whether our services was running flawlessly, or if we were impacting our customers. We additionally took information that was available in Atlas and some of our other tools to build dashboards that told us exactly who was in VPC and who was in Classic, to be able to prioritize what needed to be moved We also had hundreds of databases, petabytes of data that needed to move without any downtime. Our database engineering team spent some time developing a process that allowed things to move flawlessly. We had thousands of services that were being developed by dozens of teams who all moved independently. And finally, we had over 100,000 instances that we moved within our time frame. Netflix moves fast. And one of the things that we couldn't do was slow down how fast Netflix moves. We needed to ensure that our engineering teams experienced a seamless experience moving their applications. We wanted to make sure that the velocity of innovation wasn't impacted. So what we did was built a migration team made up of network engineering, database engineering, security, and operational folks who learned the system very well, could make changes, and give guidance to our teams. That made sure that as teams were moving, the velocity of their innovation was not interrupted by their process of moving. And finally, unlike our move from the data center into the cloud, we had only taken advantage of things I can't say that word, only taking special things into consideration. We were not going to change the velocity of our move for changes that would be beneficial to our environment. We also broke down our services into very simple classifications. The criteria was size and criticality. Simply, if an application was over 200 instances, it was considered large. And if a system would stop something from a customer from streaming, it would be considered critical. We also knew that our holiday season was a special season for our customers. That's when they gathered in their hometowns, they met their friends, they had brand new devices that they wanted to plug in and see stream. So we set our timeline between January and the end of September to ensure that we were completed with our migration before the holiday season. We had made many changes to our environment and our tooling in 2015, and we were ready to open the gates for the systems to migrate. But we had made lots of assumptions that we didn't know were valid or invalid. So we opened the gate for our small non-critical applications, and during that first few weeks, we hardened our infrastructure, we tested our assumptions and made sure that our tooling was working as we expected. We also had applications and services that did not move quickly. So we opened our gate for those systems that were going to take the entire 3 quarters to move. The next area that we opened a gate for was non-critical but large systems. Those were the over 200 instances where we needed to develop a process to move our reservations from EC2 Classic into VPC. That ensured that we had enough capacity to move the application without issue. And then finally, our critical apps. Those are the ones that if we moved poorly would impact our users. We managed those tightly and well. And then finally, starting in October, we had our cleanup activities that I'm not going to talk about. So now I want to hand this off to Andrew.
Cool. All right, thanks, Lori. As Lori mentioned, we built a mountain within EC2 Classic. Now, in order for Netflix to take advantage of all the benefits from VPC, we needed to think about and understand what are some of the behavioral differences that are within VPC. Now, we built quite a few tools and services in in Classic, and based on those behaviors, we had certain things in mind. So we need to understand what are some of the new features we can take advantage of? What are some of the changes we needed to account for? Once we understood what those changes were, we leveraged our partnership with AWS. Now, we have a great partnership. And in knowing that, we explained to them how we wanted to move, what are some of the things we were thinking about, bouncing ideas back and forth off each other. And knowing what they were going to deliver, I'm going to kind of walk you through the journey in terms of 2016. Once we understood what our ideal state was going to be, that was effectively going to be our North Star, our guiding light. Anytime we made critical decisions, we always wanted to ensure that we're actually moving towards that final state. With that being the case, we also wanted to figure out what's going to be our overall migration plan. Now, how many of you guys have heard of chaos engineering? Show of hands? All right. So we've actually gotten pretty good at this in terms of failing over our service between regions, and we do this quite often. So one of the models we thought about in terms of migrating services was actually kind of doing the big bang. We thought about, all right, let's build up the entire environment within VPC and simply fail it over out of Classic into VPC. One of the issues that came out of that is that it was going to take a huge amount of coordination with all the engineering teams to get them all aligned. So that wasn't really going to be the ideal method. The other option we thought about was really kind of mimicking Classic to kind of minimize the overall changes as we moved from Classic over into VPC. And what I mean by that is, effectively, if you think about it, public subnets within VPC are really similar just to the general network within Classic. Deploy instances, they have the ability to get public addresses, and they also have private addresses. But in going that route, we'd probably lose a lot of advantages of actually taking or putting systems into the private subnets. So ultimately, we decided to go with the new frontier. We effectively planned on moving services slowly into VPC, leveraging ClassicLink, which we'll talk about in a bit. Now, as far as our technical challenges, the way we wanted to group these was really around trying to minimize the impact to the rest of the engineering teams at Netflix. We wanted to group it in a manner where most of the work was done by as few teams as possible. And of course, it just so happens that most of the work that needed to be done really revolved around network routing. How do systems communicate to one another as they move over to VPC, also ensuring they can still communicate across accounts, and also to the third-party partners. The other major area of concern revolved around DNS. There were some distinct differences between the way DNS behaved inside of EC2 Classic versus VPC. I'll get more into that a bit later. Lastly, security groups were the things we really needed to think about. Now, it's very related to how traffic flows across the environments. And the last thing we wanted to do is actually compromise our security. We don't want to have to open up, all the security groups just to make the migration easy. We're always thinking of how do we overall just improve the environment and incrementally improve security. Prior to actually moving things, we thought about early on what our account strategy was going to look like. Over time, a majority of the Netflix services, the streaming services, are actually within a few key accounts. Those have grown organically over time, which has caused, a bit of confusion in terms of what is the primary purpose of it, different deployment models, different security groups, and also kind of creates a very complex, data flow model when you have to map out what are all the dependencies between those environments. So some of the things we thought about were really around security compartmentalization. If there was a compromise, if there was a breach, can we somehow take advantage of accounts to either slow that down or contain that breach? The other thing we thought about was really the administrative domain. We want to ensure our engineers have the ability to deploy and manage their systems as needed and give them the necessary permissions to do everything they need. But at the same time, we also wanted to ensure that we didn't give them too many permissions. For example, we didn't need to have our finance team to have full access to their Classic environment and or VPC, same as any other internal team. The other thing we thought about at scale is really rate limits. Now, oftentimes you hear, hey, the cloud, it can infinitely scale. But at our scale, we often run into kind of those upper limits. And with AWS, some of these limits are really bound around accounts. And so if we're able to decompose our accounts into smaller subsets, we'd reduce our likelihood of actually hitting these upper bounds. Things like, API calls. We do thousands of calls a second. Sometimes we do hit those upper limits. Lastly, we also thought about capacity from a couple of dimensions. So the first one is really around IP addresses. IP addresses, managing those is something new within VPC, and that's something we needed to consider, especially as we're growing, and also as far as all the other service components that actually take up addresses. The other thing we thought about was really around reserved instances. So we have multiple accounts, and we actually share reserved instances between accounts. So one of the things to keep in mind, if you guys are setting up brand new accounts, the actual AZs themselves aren't necessarily aligned. So if you have an account A, AZ A, B, and C aren't necessarily the same for your second account. So you want to make sure those are aligned before you deploy any sort of service. That way, if you want to move reservations in between, you can easily do that. Now, as far as account classification, we wanted to make this simple and easy for all of our engineering teams to remember. If you have too many rules in place, it just makes things confusing. People ask a bunch of questions, they're not quite sure where to put things, and they just end up putting it wherever. So we look at this really around business purposes. What are the services? Who are they serving? What are they needed for? To really help simplify what those categories look like. Secondly, we also thought about the operational model. Now, we have centralized teams that build a lot of tools to cover most of the internal engineering teams, but it's not full coverage. We don't have 100% adoption, which is okay. However, at scale, you want to keep things as simple as possible. So if you have a similar operational model within an account, it makes it very easy for auditing purposes and also to ensure that everybody's at the same either patch level, security level, configuration level, whatever it may be. But having consistency across the accounts definitely makes things a lot easier. And the last thing we thought about was really around user access. Who are the users that are going to be accessing these services and these accounts? Are they maybe customers that are on the internet coming into the service? Are they internal teams that need to access some of these services? Or maybe some of your third-party partners? So those are the things we thought about as we divided up our accounts. Now, from a networking perspective, we look at traffic in two buckets, really. One is really around regional routing, and the other is around global routing. Now, as I mentioned, ClassicLink was one of the key components that helped us successfully migrate into VPC. So ClassicLink really allows Classic instances to communicate to VPC instances within the same account, within the same region. So the first thing we need to consider was really around IP address allocation. As I mentioned before, this is something new we didn't have to think about within Classic. Amazon pretty much took care of that for us in Classic. Didn't really need to think about it. So the first item we had to contend with was the actual address space itself, 10/8. So I'm sure many of you with data centers, corporate offices, even some of your partners probably use the 10 space as well. So we had to figure out how do we overcome this. The second thing we thought about was really around globally unique IP addresses. We have a global footprint. We're in 4 regions, multiple accounts, multiple VPCs. With that being the case, we wanted to ensure that any sort of communication, we didn't have to contend with overlapping IP space. The last thing we needed to think about was what's going to be the proper size for us. Really thinking about scale and what the future growth is going to be, you want to properly size your VPCs. So how did we address this? So obviously there's a couple of other RFCs that have space available. The 192.168.16, it's about 65,000 addresses. We already have over 100,000 instances up and running. So if we think about that space in terms of how we fail over from region to region, even thinking about additional growth, that still wasn't going to be large enough for us. So we also looked at the 172.16/12 network as well. That's about a little over 1 million usable addresses. When we looked at that and we looked at how we wanted to decompose our accounts, that still wasn't large enough. If we actually moved into that, we probably wouldn't be able to grow over a year. So RFC 6598, the address is not routable on the internet, provides just a bit over 4 million usable IP spaces, or IP addresses, and effectively would allow us to grow for the next 3 to 4 years. Now, one thing to keep in mind about this, we knew this going into the migration, that this particular space actually was not resolvable in EC2 DNS. But I'll get to a bit that later. So, as far as IP address reservations are concerned, again, this is something new that our engineering teams needed to take up on. So internally, we built a couple of tools. The first one was Cloud IP. Cloud IP effectively allows engineering teams to reserve public addresses themselves. It's like a self-service tool. If you need public addresses, public blocks, this is the tool you could use, and you wouldn't have to worry about any sort of overlap or contention between different teams. The second thing was ENI auto-attach. ENIs were a new concept within VPC, which you could effectively move around. Now for us, the combination of this and ENI auto-attach, we could effectively tag these to our application clusters, so that way when there's any sort of auto-scaling event, any sort of chaos event actually takes out particular instances, the associated IPs still remain with that cluster type. Now the VPC Subnet Layout is something we thought long and hard about. As I mentioned before, size was definitely something of concern. And so we have 3 categories. So there's external subnets. This is effectively for services that have public-facing services. We have internal subnets. Those don't have services that need to access the internet directly. And the last one is really partner subnets. Partner subnets, they're somewhat analogous to VPC endpoints, to whereby it allows other services internally to talk to some of our third-party partners. Now, as I mentioned, planning out the size of the network is something you need to be very thoughtful about. So for us, we knew about how many instances we were going to have, what that growth rate looked like, but we also had to account for all the other service components within VPC. ELBs take up IP addresses. NAT Gateways take up IP addresses. Even launching Lambda functions takes up addresses. We actually ran into an issue where Lambda sucked up about 7,500 addresses. So you need to keep that in mind. So the largest subnet we had available to us was a /16. And as I mentioned, we're always thinking about how do we improve our overall security. So within Classic, everything pretty much had a public IP address. But all those services actually didn't have internet-facing services and didn't need it. So since we had the opportunity to actually move these into private subnets, we wanted to move a majority of our services into these internal subnets. And as far as the Netflix model is concerned, in terms of how we actually leverage VPC and AZs, we use what is known as a 3AZ model. So we use 3 AZs for every account in every region. So that way, if there is any sort of AZ failure, we can still run out of that region and not have to worry about capacity. So again, with that being the case, we needed to make the internal subnets as large as possible. So you have to cut these up on the bit boundary. So you end up with 418s. The 418s are allocated to the internal subnets. So now we're going to carve up the last 318. So now we have these /20s. We allocated those to our external subnets. Then we carved up the last 20 to 22s and allocated those for our partner subnets. So we were pretty efficient at actually maximizing the use of the IP space, especially with our 3AZ model. Now, for some of you guys that might think about using a 2AZ model, you can probably actually use the IP space more efficiently. Now, at the end of the day, this is our 3AZ model with the 3 different subnet types in each AZ. Now, as I mentioned, one of the things we did want to do is actually bring a lot of these services into the internal subnet, which means if it actually needs to go out to the internet, it still needs to traverse the NAT gateway. Now, in one of our regions, we probably push an average probably about 50 gigabytes going outbound. It's quite large. So with NAT gateways and understanding what that size were, we need to figure out how do we actually scale out NAT gateways. So there are a couple of things we thought about. So the first one was really around sharding the subnets. So in our typical model with just a single with a single subnet per AZ, you have a default gateway, points to the NAT gateway. Oh, that's great. But what if we actually shard that route? Make a high side of the internet, low side of the internet. Those are both pointing to 2 different NAT gateways. You can even split that even further. You can actually build some automation around this, monitoring the NAT gateways, monitor the performance. As the capacity starts to increase, you can actually launch additional NAT gateways and further carve up those subnets actually on the fly. We've actually tested this in moving traffic between NAT gateways. I think we've seen maybe, 1 or 2 packets drop, so it's actually pretty effective. But the one thing we didn't like about this is that you can potentially create hotspots. So for example, you've had one of your service clusters may be talking to one of your third-party partners. In that particular case, that third-party partner is probably within a particular IP range, which would make that traffic actually go through that one NAT gateway. And so you end up getting a hotspot on that NAT gateway. So we looked at this a little bit differently as well. So rather than sharding the actual network route, we thought about further splitting up those subnets. So you have 2 subnets. You can even break it up into 4 subnets. So each subnet now has its own route table and its own dedicated NAT gateway. And again, you can even keep going further if necessary. Now I'm going to shift gears here and talk about ClassicLink. So just to provide you guys a bit of context, we have the green account on the left, has a classic deployment and also VPC deployment. Then we have the blue account, same thing, classic and VPC, and this is all within the region. Now, as I mentioned, when you think about classic and how your classic instances actually communicate to one another, all that traffic is actually private. So for example, if you have services that are in the green account, they want to talk to the blue account, that actually works as expected. When you make a public DNS call to the other account, you actually get back a private address. So you can think about it as one big private routing domain. So everything within a particular region is all actually a part of that 10/8 network. Now, with that being the case, when you turn on ClassicLink, in the way those systems actually communicated, we needed to ensure that it still had that same communication flow. So if we migrated the system, our expectation was that you could actually still talk to it. Now, when I circle back to the issue I mentioned earlier with that RFC 6598 as far as the 1064, those addresses were not resolvable by EC2 DNS, and so we knew this. What ended up happening is you actually got back the public address. And so when that system wanted to communicate to a system that migrated into VPC, that traffic would actually go outside, externally, and if it hit that security group, it wouldn't be allowed in, because now it's external traffic. So how do we address this? So most of our service uses Eureka, which is open source. It's our service discovery. And in knowing this, Eureka actually has the ability to capture 4 different attributes. You can get the public host name, the public address, private host name. All these are in there. So what we ended up doing to kind of buy some time was actually modify the behavior as systems were deployed into VPC. For the systems that were deployed into VPC, rather than registering with their EC2 public hostname, we'd have them register with their private address. So that way, when a service inside of Classic attempted to talk to the service that migrated into VPC, it'd actually get back the private address directly. Therefore, we eliminated the issue in the manner in which the EC2 public hostnames were resolving. Now, while we knew this was the case, as I mentioned, at the same time, Amazon is also working on a couple other features to actually address this, because not everything within our environment actually uses our discovery service. And so in order to fix this, they worked on a feature called DNS over ClassicLink. And what this did was actually mimic the behavior and how DNS worked when it communicated across accounts within Classic. So when you call the EC2 public hostname for a service that's in VPC now, you actually get back the private IP address, which forces the transport to go over that internal connection. So now we had to consider, how do we allow systems to communicate to other accounts as they migrate? Because you get this crazy matrix. So ideally, we should be able to communicate to this in the same manner as it was within Classic. But again, we ran into a similar issue. So based on the timing, we knew we wanted to move, and we had to start early in January. Based on our timelines, we wanted to ensure that we're actually done before we got to the holiday seasons. So with this being the case, we knew Amazon was also building additional services to account for these particular use cases. So there are two things they worked on to help people migrate from Classic into VPC. So the first one was ClassicLink over peering. So you needed to peer the VPCs from the two accounts, and this would actually extend the ClassicLink functionality into that second account for that VPC. And again, the second piece was really around DNS. So the DNS over peering feature allowed communication between these two accounts, two environments, to resolve back to the private address. Now, when you stack all these features together, you have ClassicLink in one account, your second account, third account, fourth account. What we ended up doing is actually creating the fully peered mesh of VPCs on the back ends. And once this was done, you can effectively think of it as a single routing domain. So no matter the order of operations in which you move your systems, you would still have that communication flow between those services. Now, once we address the transport layer, we need to figure out, how do we manage ClassicLink at scale now? Now, we have thousands of services within Classic and also within VPC. And so with that being the case, there's thousands of auto-scaling events that happen on a daily basis. And we needed to ensure that ClassicLink was enabled for all of these at all times. So three particular scenarios we had to address. So the first one was around addressing new services we deployed into VPC. Sorry, Classic. Once those services were deployed into Classic, with the new configuration, we knew ClassicLink was already going to be automatically enabled, because that feature was actually added to the pipelines. So when they used Spinnaker to deploy those, ClassicLink was already on. The second use case we needed to address was really around instances that were running. In some cases, people would deploy stuff, and they might not push code for a quarter, which is perfectly fine. But we needed to account for ensuring that those services had ClassicLink enabled. So we built a service internally that would actually sweep the entire fleet and enable ClassicLink on all those instances. So that addressed those particular instances. But now we also had to account for auto-scaling events. So in those cases, if an auto-scale event actually happened, it launched without ClassicLink, which was going to be a problem. So we had to ensure that wasn't going to happen. So what we ended up doing there is we actually went through, swapped out all of the launch configs, placed new launch configs in place that actually, when an auto-scale event occurred, it actually launched the new instances with ClassicLink enabled. So that's how we accounted for that. Now, as Laura mentioned, we had to categorize our services And this is really around the order of operations to ensure that we wouldn't run into any sort of problems as far as communication flow, because we knew those features from Amazon were coming. And so what we ended up doing was actually mapping our dependencies. So we raked the flow logs. We also raked some services off the actual instances to determine what are all those dependencies, what services talk to one another. We also enhanced that with some metadata to figure out how do services communicate to one another, what services are being leveraged. So for example, your service talk to say SQS, S3, things of that nature. We wanted to know what that actually looked like and did that sort of analysis. And so early on during our migration, we only wanted to migrate services that only had internal communication within a single account. For the more complex services, for services that had cross-account communication, we held off until those new features were available from AWS. That way, that would minimize the disruption in terms of how the applications were able to communicate to one another. Now, as far as global routing is concerned, with VPC, it has the advantage of connecting on the back end with either a VPN or Direct Connect. So in our case, we opted to use Direct Connect. We use Direct Connect to provide high redundancy between our POPs, in addition with our global backbone, to provide full communication pathways between all of our regions. This was also one of the reasons why we wanted to have globally unique IP addresses to ensure that there wasn't any sort of conflict. Now, once this was in place, one of the things people should also think about is when you have multiple accounts and you're trying to enforce separation between those accounts, you should also think about how do you enforce that separation at the network layer. So if you have these test accounts and they should only talk to one another, even though they're globally dispersed, you can actually enforce that on your backbone. So one thing to keep in mind. Now, even with the backbone in place, we still had some other issues we had to account for. So we have labs that are on-premise that test like Xboxes, PlayStations, TVs, things of that nature, that actually need to talk to services in the cloud. So there's a problem since we actually use the 10 space. We thought about actually re-IPing the offices. That was going to be a huge undertaking. There are already a ton of tools and services around the labs and those functionality. So we looked at other options in terms of trying to minimize the disruption to other teams. So rather than having our lab engineering team modify all their tools, we wanted to see if we could somehow take care of this at the network layer. We're already doing a bulk of the work, so just some incremental work for us. And so when we looked at this, obviously the expectation was for the labs to be able to communicate to those services once they moved into VPC. However, once you turn on ClassicLink, effectively the lab space, that route was hijacked. All that traffic would now flow into to Classic because of ClassicLink. You inherently get that 10/8 network that just points to local. So there were a couple of things we had to do to address this traffic flow. So how do we do this? So we looked at a couple of things. So one, we needed to NAT the traffic going into the lab space. So the way we actually IP'd our offices, our lab space, we kind of accounted for a variety of different scenarios. And with that being the case, we were actually able just to simply swap out the first octet with a different octet. So that's how we actually NATed that particular traffic. So that helps that addresses the communication between the VPC with ClassicLink enabled going to our labs. Now the second piece we needed to address was really around DNS. So when services communicated to the labs, they use the local resolvers in those labs. Those lab resolvers would actually return with the 10 address, which again is going to be a problem. So we built custom DNS servers in VPC. All those instances leveraged those custom DNS servers, and when they communicated with the labs, those custom DNS servers would actually intercept the response and also modify that octet. So now we have the DNS response modified and also the octet modified at the network layer, and effectively communication would flow between all these. So if you combine, ClassicLink, peering, the NATing we get on the back end, Effectively, our global infrastructure can now communicate without any sort of IP conflicts. So what did we learn from this? There are key things to think about. So one, as far as the IP address scheme, is really around making sure that's really global unique, just to avoid all these conflicts. Having to re-IP things is not an easy undertaking. It's quite a pain. The other thing you want to think about is really around traffic patterns. Understanding traffic patterns really helps to figure out what is the right order of operations in terms of how you actually migrate your systems from Classic into VPC. This was definitely key for us, especially knowing that there were new features that were going to address some of our pain points. One of the other things to really consider is partner engagement. We work with a lot of third-party partners. So you want to engage with these folks very early on, especially around whitelisting particular services. In some cases, we had some folks that took a few weeks to actually update their whitelists. So you want to give them enough heads up as possible. The last thing I thought about was reducing our technical debt. We definitely wanted to leverage the opportunity as we moved over from Classic into VPC to reduce as much technical debt as possible. But at the same time, we didn't want to have the technical debt actually paralyze us and not move. So it's okay to bring some of that stuff over, but just think about what are the things you would bring over and how you'd actually address that at a later date. Now I want to circle back with all these features and things that were added on. So we have ClassicLink, we have ClassicLink over DNS, we have DNS over peering, we have EC2 DNS support for non-RFC 1918 space, we have our ClassicLink service. We had all these things we put together. Now we put them all together just so our engineering teams can actually hit that easy button. One click of the button, the service migrates from Classic into VPC. All the heavy lifting was done on the back end. So in February, that's where we're at. And as of today, we migrated over 99% of over 100,000 instances by doing all this work. We now have a new mountain in VPC. Thanks. So I believe there's an eval to complete, and then we're going to allocate at least 15 minutes for questions, but here are some other related talks from Netflix.